Hello students, welcome back. Let us continue with chapter 10, circles. We'll take a look at a new concept, that is angle subtended by an arc of a circle. So let's draw a circle. Ignore this theorem, the statement of this theorem for the moment. We are taking a look at this section. So if I have a circle with center O and I'll say PQ is the minor arc, right? Then angle subtended by an arc of a circle. So this arc can subtend an angle at the center as well as any point on the circumference. Let's say this. So if I have O as the center and M as any point on the circumference of the circle, then these two angles POQ and PMQ are subtended by the arc PQ. Now if I join these points P and Q, I will get the chord PQ. So corresponding to this minor arc PQ, I have a chord, that is chord PQ. So what can we see? We will conclude these 3 points, that if two chords of a circle are equal, then their corresponding arcs are congruent. Why? Because if I have, let's say first one circle only, I'll say if two chords of a circle are equal. So I have chords PQ and MN, let's say. If you take a circle, if you draw a circle on a piece of paper and you mark equal chords on the circle and you cut out these sections PQ and MN, you will notice that PQ will completely overlap with MN. So they are not just equal, but they are also congruent. So if two chords of a circle are equal, then their corresponding arcs are congruent, and vice versa. If two arcs are congruent, then their corresponding chords are equal. So if I have only PM and QN left from this circle and I add these congruent arcs PQ and MN, so this is PQ and MN, it will give rise to a complete round circle, let's say with center O. So this is the other point. So congruent arcs or equal arcs subtend equal angles at the center. Why? We have learned at the start of the chapter that two congruent chords will subtend equal angles at the center. Now these congruent chords will correspond to their respective arcs, that is PQ, chord PQ will correspond to arc PQ and chord MN will correspond to arc MN. Now these chords are subtending equal angles at the center, that is MON is equal to POQ. So obviously these angles are also subtended by the congruent arcs PQ and MN. So this justifies the point that congruent arcs or equal arcs subtend equal angles at the center. So we are just going to use these points and then we are going to prove Theorem 10.8. Let me erase the board for now and then I will read out the statement for you. The angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So what they mean to say is, if you have a circle with center O and if the angle subtended by an arc, and if you have an arc, let's say PQ, subtending an angle at the center, so let my center point be O, then arc at the center is double the angle subtended by it at any point on the remaining part of the circle. So let this any point on the remaining part of the circle be point M. So like I told you just a while ago, angle POQ is subtended by arc PQ and angle PMQ is subtended by arc PQ. I need to prove that angle POQ is twice angle PMQ. So this is not just one diagram that we can draw two other types of arcs in this way, because we also have the arc of a semicircle which passes through, whose chord will pass through the center of the circle, right? So I can have arc PQ like this as well. So this is my figure number 1, this is my figure number 2, and here I need to prove again that POQ is twice PMQ, and there will be another case. See, here we have taken PQ as the minor arc, then we took PQ as the arc of a semicircle. Now we will take PQ as the major arc. So let's say this is my point here, O, and PM is here. So how do we prove that? Let's mark the figures 2 and 3. So how do we prove that POQ is twice PMQ? So let us first write the given. In the above circles, with center O, arc PQ subtends angle POQ and angle PMQ at the center and circumference respectively. To prove that angle POQ is twice angle PMQ. So what we are going to do is, we are going to join points MO and extend it until point B. Let's say this is point B. Here also let's do the same thing. So this is going to be a construction, join MO and extend it until point B. Now if you notice, angle BOQ is the sum of angle OMQ and OQM. Why? Through exterior angle theorem. But if you notice, OM is equal to OQ because they are the radii of the circle. Therefore, these two angles OQM and OMQ are equal. Therefore, BOQ is twice of OMQ. Similarly, BOP is twice of OMP. Therefore, when you add BOQ plus BOP, you will get that equal to twice of this angle, that is OMQ plus OMP. Therefore, POQ is twice of PMQ. Let's go ahead and write the proof, and then I will tell you special proofs for these two. So first of all, we'll start with a proof. Construction. Join MB, MO and extend it the line until point B. Now triangle BOQ, angle BOQ is equal to angle BOM plus angle BQM, OQM. This is OMQ, MQ and OQM. Why? Through the exterior angle theorem. So BOQ is OMQ plus OQM through exterior angle theorem. For those who did not get it, let me draw this for you so that you will understand better. See, we have a figure like this. You have B out here, you have O out here, M out here and Q out here. So B is the exterior angle for the sum of these two angles. If you still did not get it, let me tilt this for you and make you understand better. So this is B, this is O, this is M and this is Q. Now makes sense, BOQ is OQM plus OMQ. Simple, isn't it? Through exterior angle theorem, because BOQ is the exterior angle for this triangle and we know that the exterior angle is twice the sum of interior opposite angles. So the adjacent angle is never considered, but the interior opposite angles are considered for the exterior angle theorem. So I'm erasing this for now. But, so let's mark this as 1. But what do we know? That OM is equal to OQ because they are the radii of the circle. Therefore, triangle OMQ is isosceles with angle OMQ is equal to angle OQM. Let's mark this as 2. So from 1 and 2, what can we write? That angle BOQ is twice of either OMQ or OQM. But since we want this, we need to prove that this angle is twice this angle. We are going to take into consideration twice of angle OMQ. Therefore, angle BOQ is twice of angle OMQ from 1 and 2. Correct? Let's mark this as 3. Similarly, I can say that angle BOP is twice angle OMP. Let's mark this as 4. So when you add 3 and 4, you will get equals. When added to equals, the wholes are equal. Therefore, adding 3 and 4, I get angle BOQ plus angle BOP is equal to twice angle OMQ plus angle OMP. Now BOQ plus BOP is POQ. So angle POQ is equal to twice angle OMQ plus OMP is PMQ. Hence, we have proved what was needed out here. So here I will mark this as Roman number 1. And we will go about and see special proofs for figures 1 and 2. For 2 and 3. See, the same proof is applicable, that is twice POQ is twice PMQ. That is the angle subtended at the center is twice the angle subtended at the circumference of the circle. But for these ones, see here we have a semicircle. So if you notice that POQ is 180 degrees. Why? Because POQ is a straight line. So for figure 2, what do I have? Angle POQ is equal to 180 degrees. Since POQ is the diameter, is a straight line and diameter. Correct? Therefore, from 1, angle POQ is equal to twice angle PMQ. That is 180 degrees is equal to twice of angle PMQ. That is angle PMQ is equal to 180 degrees divided by 2, which is equal to 90 degrees. So what is the special case out here? That angle subtended by a semicircle is a right angle. So whenever you have a diameter that is subtending an angle at the circumference, or if you have a semicircle subtending an angle at the circumference, then this angle subtended at the point on the circle is a right angle. Okay? And the special case for this one is, so I'm erasing this section for now. See, here we had the minor arc PQ, but here PQ is the major arc. So instead of angle POQ, we say reflex for the major arc. So now for the third section for figure 3, since PQ is the major arc, I will say that reflex angle POQ is equal to twice angle PMQ. So for the minor arc, it just goes that way, is that POQ is twice PMQ, angle subtended at the center is twice angle subtended at the circumference. For a semicircle, the angle subtended at the circumference is 90 degrees, and for the major arc, reflex angle subtended at the center is twice the angle subtended at the circumference. So we will go ahead and take a look at a special proof related to this. So again, I am going to redraw the figure. Okay. I have, let's say, minor arc PQ subtending an angle at the center O, so angle POQ, and one angle at the circumference as angle PMQ is angle subtended at the circumference. So if I join these points of my arc P and Q, what will I get? That angle PMQ is subtended at the arc in the segment PMQP. If I draw another angle subtended by the arc PQ, let's say PNQ. So angle PNQ is subtended by arc PNQP, and angle PMQ is subtended by arc PMQP, or by segment, not arc, by segment PNQP. But both these angles PNQ and PMQ are subtended by the same arc also. So this is just the way you denote it. If you are trying to denote the angle subtended at a point on the circle, you mention the segment as 4 alphabets out here. It would be your arcs and the points included. So you start from P, you go to N, you go to the arc's endpoint again, and then you complete the loop. So it's PNQP, and similarly PMQP. So this is just the denotion. Now arc or angle PNQ and angle PMQ are subtended by minor arc PQ, correct? Therefore, angle POQ is equal to twice angle PNQ, and angle POQ is twice angle PNQ. Why? Because POQ is the angle subtended at the center. We just learned previously that the angle subtended at the center is twice the angle subtended at the circumference. So this is the angle subtended at the center, twice the angle subtended at the circumference. From these two, what can you say? That angle PNQ is equal to angle PMQ. So from this, we arrive to our theorem 10.11. Sorry, theorem 10.10. Let me just confirm the theorem number. So this is theorem 10.9, that angles subtended in the same segment of a circle are equal. So which are the two angles subtended in the same segment? You have PNQ and PMQ subtended in the same segment. So this is your segment. They are the same segment. So these two angles are equal, or angles subtended by the same arc on the same side of the circle or on the same side of the segment are equal. So this was about Theorem 10.8 and 10.9. We'll take a look at Theorem 10.10 in the next video. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.